So I was asking one thing. Okay, so let's continue with that. So it was like I gave you x versus t graph and was asking concerned about the v versus t graph of this. So let's look at closely. You can feel that this is this was x versus t, v versus t I need to find. Now this is a parabola, I told you, an upward parabola, so acceleration would be positive. Even you can see the slope and you can find that the velocity is increasing, but what my point is, velocity would be a straight line starting from zero. Velocity would be a straight line. Okay, because the graph of x versus t is a parabola, so velocity in this case is a straight line. And if I draw like one x versus t is like this, so it is you can see the slope of this, the second one, the red one, is not zero in the starting. It's not touching the x-axis. So the velocity versus time of that would be again a straight line, and acceleration would be positive, so increasing straight line, but not starting from zero. So this was my point. And similarly, if I ask you, another one like this one, blue one like this, okay, so this would be again, but can you see that? Can you see that it would be zero, but its slope is negative, so the velocity would be this. Slope is negative, you can see that, and it's starting from zero. And another one like this, if I say that, okay, I'll draw it with a different color. If I draw it with a green, and I draw it like this, so it would be v would be negative, but not starting from zero. Okay, because it is not zero in the starting point. Okay, so these were the few points I just want to clear before starting some problems, some good problems over it. So now I ask graphs in terms of some problems. So what is the problem? Say I give you one problem. Okay, if I ask you which graph is the best to represent the situation, x versus t, v versus t, or a versus t, which one of the graph is more helping, more resourceful out of the three? It's v versus t, because if you find the area of that, you would find the displacement. If you find the slope, you could find the acceleration. So you can go both ways. So v versus t is the most beneficial graph. Okay then, cool. So I give you one graph like v versus t, and it is like this. Constant, no, increasing, but acceleration is constant, and then constant, then decreasing, but at a constant rate. So this is, say for example, this time is t1, and say for example, this time is t2. Okay, so this is v versus t graph I gave you. And if I ask you x versus t and a versus t, you need to find. So a versus t is pretty simple. Let's work over x versus t. Okay, let's work over x versus t. So say for example, can you see that the velocity versus time from 0 to t1 is a straight line, and which one is increasing? Acceleration is positive, so it has to be a parabola. Okay, then my question is, upward parabola, downward parabola? Upward parabola, like this. Then afterwards, can you see that velocity is constant? So x versus t would be a straight line because the slope is constant, x versus t. Okay, then afterwards it is from, this is, say for example, this is t1, then t2, t1 to t2, it is constant, velocity is constant, so x versus t would be a straight line. Then afterwards from t2, velocity is decreasing, not constant, but with a constant rate, so it would be a parabola, x versus t, but a downward parabola, and it's getting zero, so it has to be flat at this point. Say for example, this point was t3, So it should look like getting flat. So slope is getting 0 at this point. I'm just representing it with, you know, dark black color so that you can see that. Okay. Moreover, if I'm asking acceleration versus t, I am just showing it here only. Acceleration versus t. Okay. Acceleration versus t. First of all, from 0 to t1, velocity is increasing at a constant rate. So acceleration is constant. So acceleration is constant from 0 to t1. And then from t1 to t2, velocity constant, so acceleration is 0. And from t2 to t3, acceleration is negative. As velocity is decreasing, you can see that slope also is negative. Okay, so from t1 to t2, acceleration is 0, velocity is constant, and after t2, velocity is decreasing, acceleration is negative. That's it. So this is the acceleration versus t graph. Out of the following, acceleration versus t would always be going to be easiest one. Okay, so I hope you got these things. Okay, let me give you another graph just to, you know, help you with the concept. So this time again I give you v versus t graph, velocity versus time graph. So initially the velocity was constant, then it was decreasing. Say for example, it started with a 10 meter per second. Okay, then in 1 second, till 1 second it is constant. Say for example, this is 1 second. At 2 second it is getting 0, and at 3 second it is getting, say for example, minus 10. Okay, and this time you can take as 3 second. So this was velocity versus time. So question is, draw x versus t, and acceleration versus time you can easily draw. So that is not an, you know, challenge over there. X versus t, let's draw x versus t. We'll give our full focus to x versus t. Okay, so let's draw this x versus t. Even you can draw yourself by a versus acceleration versus time graph. Actually I was thinking to, you know, formulate one another question for you. So just look it, you know, very attentively. I'm just drawing solution here only so that you can you know, actually compare. So x versus t I'm drawing here. So what is the question? Velocity is constant first of all. So if the velocity is constant, so x versus t would be a straight line. Okay, and velocity is positive, so it would be like this only. Okay, a straight line till 1 second. So I can say that this is 1 second. Now acceleration, velocity is decreasing. Sorry, acceleration velocity is decreasing, not acceleration. Velocity is decreasing. So that's mean, you know, x versus t would be a parabola. It's a straight line. Now afterwards, from 1 second to 2 second, it is a straight line even. Okay, decreasing as well as straight line. So it would be parabola, upward or downward. It has to be a downward. Okay, and then it's getting 0. So from 1 second to 2 second it is decreasing, so parabola, and 2 second it is getting 0. So the parabola has to be equivalent to, parallel to the x-axis. So it has to be flat. So it is decreasing and it has to be a flat at this point. So 2 second. After 2 second is again decreasing. So it is again a parabola and a straight line as well. So it would goes like this. So this would be for the 3 second. Can you see that? So this is the displacement versus time. Say for example, if somebody asks distance versus time, not displacement. So in that case, can you see that till 2 seconds it would be same, because displacement is also increasing, distance is also increasing till the velocity is zero. Till the velocity is zero, body is moving away. So the thing is, displacement and distance both are increasing. But things gonna change afterwards when the velocity becomes negative. So for distance versus time, you just need to take the mirror image of this part, 2 seconds to 3 seconds. Okay, so just because the distance is always going to increase, because the distance is always going to increase, so just simple thing is to take the mirror image of this. Okay, now if you want me to solve the for acceleration versus time graph, so I can solve it. Okay, acceleration versus time, this is easy one. First of all, velocity was constant till 1 second, so acceleration would be 0. Okay, and from 1 second to 3 seconds, acceleration is constant and it is negative as well. And what is it? -5. Velocity is continuously decreasing, and so from 1 second to 3 seconds, velocity is getting 0, displacement is changing, but the acceleration is same, -5. How I found the -5? The slope of this line you can found in this triangle. You can find that same in coming in this triangle. Oh, okay, 10. It is 10. Sorry, not -5. It is 10. When you come in this triangle, it is 10 only. Okay. Just I messed up with this thing, but I think we had already solved it, so it is not a problem to you. So in this triangle, if you come in this triangle, it would be 10. So -10 would be the acceleration from 1 second to 3 seconds. Okay. So I hope everything is clear. Okay, let's go with the another problem. Problem is, I'm giving you for your practice. Again, I'm giving you V versus T graph, but a different this time. So V, velocity versus time graph, and say for example I'm starting from there in a straight line. This is, take for example, say for example this is 2 seconds. Okay, and then velocity is constant till 4 seconds, and afterwards it is decreasing, say 5 seconds. This is time, this is velocity. Okay, so and we need to find the different the major thing is I need to find x versus t, only x versus t, and let's do it fast. Okay, so let's go for the solution, and I hope this is for practice. So just find x versus t. Let's see how we're going to go for x versus t. Can you see that if v versus t is a straight line, not a constant one, so what would be x versus t? It's a parabola. Okay, it is increasing, acceleration is positive, so it would be opening upwards parabola. But can you see that the area of this and this is same, so the displacement is going to be 0 till 2 seconds. Okay, then velocity is constant, so it would be a straight line, and then velocity is decreasing, then it has to be a parabola again, but opening downwards. That's same. So this would be 4 seconds. Till 4 seconds velocity is constant, slope is constant. Till 5 seconds again it has to be parallel to the x-axis as well. 5 seconds. At 5 seconds you need to form it like parallel to the x-axis as well. Okay, so this is decreasing.